Moisture and relative humidity. Why are we interested in humidity? Well, humidity is a problem for us in buildings because of three different things. The first thing being that high humidity is a cause of condensation and wetting of building materials. So when we have a cold window in the wintertime and we have a high relative humidity in the house, we have the air, the humid air coming up against the window, cooling off, and having to give up its humidity as water droplets on the window. So we have water vapor in the air, and that's what humidity is. Humidity is just water vapor in the air. And there's nothing wrong with water vapor in the air, and there's really nothing wrong with water itself. I mean, we're largely composed of water ourselves. And so, but the problem is when we get this condensation and wetting, we're providing the moisture that's necessary for pests like dust mites and termites and cockroaches and mold and mildew. So that's why we consider humidity a problem. That's one of the reasons. The second reason is that when we have a high relative humidity surrounding building materials like drywall, wood, concrete, these building materials become a higher percentage of water by weight or moisture by weight. And the moisture is held somehow within the material as water vapor or as water or as something in between. And when we have a high relative humidity, we get an elevated moisture content, and an elevated moisture content is needed for mold and mildew to grow on that material. Mold and mildew can grow on wood, it can grow on drywall, it can grow on concrete, and that's not what we want. High humidity is related to summer comfort. In dry air, when we sweat, the sweat evaporates, and the act of the sweat evaporating takes heat away from our bodies, and that's what we sweat for, is to get rid of the heat. But if the humidity is very high in the air around us, we have trouble evaporating the sweat from our skin. The sweat has a tendency to lay there, and that is not what we consider to be comfortable. So we have these three reasons why humidity is a problem. Let's talk about what humidity is. Now, humidity in air is really relative to temperature. That's why we call it relative humidity. And air at 85 degrees can hold a lot of moisture. Air at 75 degrees holds less moisture, potentially. Air at 65 degrees holds even less. As the temperature of air drops, the capability of air to hold moisture, to hold water vapor, is reduced. So, this is 100% relative humidity. This is all that air can, at 85 degrees can hold. It's 180 grains per pound. Now, there are 7,000 grains in a pound. And it's not important that you know that, but this is the absolute humidity here. And so you can see that, you know, air at 35 degrees can only hold a small fraction of the humidity that air at 85 degrees can hold. So when we have a situation in the wintertime where we start out, say, at a temperature of 60 degrees and the air cools off rapidly, what happens? Well, we have a lot of dew on the ground. We have a lot of frost on the trees. We have frost or dew on the windshields of cars. And anything else that happens to be the coldest objects in the environment, dew and frost build up on them, because that's where the air is passing and getting cooled off and depositing the moisture. That's what happens. The air, as it cools off, deposits moisture on objects in the environment. Why does that happen? Well, let's do a little experiment. Let's start off with air at 85 degrees Fahrenheit at 50% relative humidity. Okay, so we've got this much humidity in the air, and we're going to cool it off to 45 degrees, and we're going to see what happens. So how do we do that? Well, we draw some water, some hot water from the faucet, we measure it, we let it cool down until it's 85 degrees. And so we have a thermometer in the glass, and we add an ice cube, and we stir it up, and now it's 75 degrees. And we stir it up a little more, now it's 65 degrees, we add another ice cube, we stir it up some more. We get all the way down to 45 degrees, and right at 45 degrees, we notice that these droplets start to form on the glass. The minute those droplets start to form, we look at the thermometer, and we see that it says 45 degrees, so we can say that 45 degrees is the dew point of that air, because that's when the droplets started to form. That's when the air around the glass became saturated to 100% relative humidity, 100%. And at 100%, the droplets will start to form. So the air out here, because it was cooled down by the ice and the cold water, the air out here went from 85 down to 45. It's just going to be the air that's close, very close to the glass. And that air starts to give up its moisture as droplets on the glass. So the moisture was formerly in the air, but now it's on the glass. And the reason why it's on the glass and not in the air is because as we reduced the temperature of the water and reduced the temperature of the air out here next to the glass, we reduced the ability of the air to hold on to the water. Let's look at this on this chart. We started off with air at 85 degrees and 50% relative humidity. Look at all this moisture that we have in this air here. Now when we get down to 45 degrees and 100% relative humidity, that's all that can fit in 45 degree air, is this much. So if we follow this over here and we look at the difference between this and this, we've got about 50 grains per pound. So if this was somehow a tremendous temperature change outside, if the air temperature actually went from 85 down to 45, which it could here in Montana, it could do that in one day. We could have a 40-degree difference in temperature. Well, we would have a lot of dew on the ground. We would have a lot of condensation on different types of objects in the environment, because we would have to lose, each pound of air would have to lose about 50 grains of water vapor, and the water vapor would turn into water, and it would turn into water and form droplets on objects, on the coldest objects in the environment. So, if you walk into a room in the wintertime, and this room is very, very humid, and you see that there's a little bit of condensation here on the wall, and there's some condensation over here on the window, and there's some condensation over by the threshold of the door or something like that. What does that tell you? Well, it tells you that those are the coldest areas in the room, because those areas are cooling down the air that is near them. That air is depositing the moisture that it can no longer hold on to on those cold surfaces. And that's something called condensation. It's something we don't want because it wets the building materials, and it allows pests to get a foothold in those materials. So, relative humidity, very important concept. Humidity is relative to the temperature. And you can see that 50% relative humidity at 85 degrees is contains more moisture than 50% relative humidity at 75 degrees, and that contains more water vapor than 50% relative humidity at 65 degrees Fahrenheit, which contains more water vapor than air at 55 degrees Fahrenheit and 50% relative humidity. This is 50% relative humidity. All of these blue areas are 50% relative humidity, but they contain different amounts of moisture in absolute terms because air at different temperatures has a much different ability to hold on to water vapor.